Okay.
Hello everyone, I'm Nguyen, and today me and Tony is presenting detailed SHA-256 algorithms. Next slide. Um, so here are some features of SHA-256 algorithms. It has fixed round key, means we know the round keys from the very beginning, and the behavior is completely unpredictable, which means you cannot guess the ciphertext from the plaintext. Is always output 256 at the 2512-bit strings, and it has excellent avalanche effects, which mean one layer change in the plain text, the ciphertext will change completely. Next slide. Before we start actually hashing, here are some things for you to know. Um, These on the screen are the hash initial values from H0 to H7. And they are the first 32 bits of the fraction parts of the square root of the first 8 prime numbers. And for example, the H0, you can get the square root of 2, which is the first prime number, then get the first 32 from its fraction part and translate that into the hex. That is H0. And so here's on the screen are the 64 hash constants. And they are the first 32 digits of the fraction part of the cubic root of the first 64 of a prime number. And here's on the screen are the functions that we are going to use or process. And they are CH, MA, in big sigma 0, big sigma 1, big sigma 0, and small sigma 1. The S mean they are right rotate. They are right shift, then prepend the shift digits to the beginning. The letter R means logical right shift, and sign is just logical end. And plus sign is the circle. Is the plus sign with the circle is the XOR, and the negation sign is negation. And one becomes zero, and zero become one.
Okay. So now we actually start the hashing process with the padding. What we want to achieve is padding the input string to the length of multiple of 512 bits. Here's an example with letter ABC. We're going to use ASCII chart to convert letters and signs to number. So ABC will become this. Note that the length of this is 24 bits. So next step will be append 1 to the end of this string. This is not actually string, it is a binary string. And then append a bunch of 0 to the end, making the total length become 448 bits. Now we want to append the length of the binary text into the end, which is 24, as I mentioned just now. And 24 in binary is 11000. So we append that to the end. And then we're going to put a bunch of 0 before the length, making the total to become 512 bits. So next step will be dividing. We're going to divide the padded binary string into 5 12-bit chunks. And we're going to divide each chunk into 30-bit words, 32-bit words, so 16 words per chunk. SHA-256 will hash these words 64 times and put all of them together, then become the final result. For demo purpose, we're going to only show the hashing of the first word of the first chunk for only one time or one round. In the picture here, A through H, they are the hash initial values. They are the same as H0 to H7 in the beginning. Red boxes here is just plus sign, but it's plus with mod 2 to the power of 32. So keeps the length to be 32 bits. WT is our 32-bit word, and KT is one of the hash constant. So T is like the index number. Since it's the first round, T equals to 0. Notice that we have 64 rounds in SHA-256, but there's only 16 word in one chunk. So we're going to use the functions mentioned above to calculate the rest of the words. So here's the function WX. So word X equals to this. It uses a small sigma 0 and a small sigma 1 function above. So this is the pre-processing steps of the hashing. So calculate the round key. So actually A, B, C, D, E, F, G, H, and WT and KT, they are all round key. And we'll create T1 and T2 for future use. T1 using the CH function, and the input will be EFG, and big sigma 1 is also used in T1, the input is E, and also add the W0, K0, and H. Notice that this plus sign here is the same as the red box is here. It's plus with mod of 2 to the power of 32. And T2 will be MA calculation, MA function with input of ABC, and we also use big sigma 0 with A as input. So notice that there's a new series of A, B, C, D, F, G, H being created. They will be used as the next. They will be used for the next round. And new A is just equals to T1 plus T2, and new E becomes D plus old D plus T1. So each round A and E changes. So one round only change one A and E, but in the next round, A and E will also be changes. So new B is just A, new C is just B, and so on. So as we go on, all the A, B, C, D, F, G is going to be changed. We will also use the new A, B, C, D, E, F, G, H to update the result, which is H0 to H7. At the beginning, they are just hash initials, but there are also global variables to this program, and we're going to update them every round. And in the end, they will become the final output. So H0 is equals to new A plus H0, equals to H0 plus new A, which is just plus equals, and the rest is the same. So final result will be H0 plus H1 plus H2 plus H3 through to H7. And this is after 64 rounds. They have been updated 64 times. Note that the plus here is append. Okay, now Tom will use the program we wrote to perform a demo.
So, be sharing my screens for the
Yeah.
demos.
Your screen.
So, can you see my screen?
Yeah.
Yeah. So, I will be performing the hash algorithm with the for the demos. So for the first part, we will just enter the plain text that we want to do this SHA with. So for demo, I will just go for ABC. And for the first step, the program will convert the string we input become ASCII, and so you can see that from A, B, C, from A is this binary, and for B is this binary, and this is for C. And so for the next step, we will use padding string into a right length. So the output is the original plain text that you can see here, and the program will add the paddings accordingly to fit with the requirement. And then the last part is the length. And after this step, we will choose the round that we want to encrypt. So for the first round, I will run with verbose, which you can see the functions of MAJ, SO, S1, and CH. So you can see here, for the first round of ABC, this will be the functions, the output. And after that, it will produce the result of the first round. And if you want to see the full functions of SHA-256, 256, we'll run the 64 round, which is a default settings. So as you can see here, this is the output of the program running the plaintext to SHA-256. We can just compare this part with the online result to check if our program is running properly or not. So here are these online tools that I found that can convert the plaintext to ciphertext using SHA-256. And for the comparison, you can see that, so it will be BA781, and right here is BA781, or check the last part is 2001 and 5 AD. So as you can see, the program works perfectly, and we get the ciphertext of SHA-56. You can try with any rounds you want. For example, we can try with 32, and you got a different result. Or you can try with 10, for example, and use verbose to see each functions they generate. And eventually, you will get the result of 10 times, 10 rounds. So that is the demo for hashing.
Okay, thank you for your time.